Assalamualaikum and hello. My name is Wan Muhammad Ali Shawar bin Hasman and my metric number is 08DKA22F1055.
Assalamualaikum and hi everyone. My name is Afiq Aizat bin Saharuddin and my matrix number is 08DKA22F1240.
Assalamualaikum warahmatullahi wabarakatuh and greetings everyone. My name is Muhammad Alif Aiman bin Arshad and my matric number is 08DKA22F1232.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saiful Hasnizam bin Abu Hassan. My matric number is 08DKA22F1067. I'm from DKA2C.
Introduction of integration. Integration is introduced as a itself process to differentiation which has wide application, for example in finding areas under curve and volume of solid. In this chapter, we shall learn how to recover the differentiation operation of the function. In short, we can say the integration of function is to get an original version of the function f bracket x from the derivative f prime bracket x to integrate the process. Let us follow the following. This example, what is meant by integration?
From the picture above, given that fx equals to 3x squared. In differentiation, we are differentiating 3x squared. We then get f prime x equal to 3 times 2 x power 2 minus with 1, and we will get fx equal to 6x. From the answer that we got from differentiation, in integration, we are reversing the process to get back the question given. So, from the differentiation answer is f prime x equal to 6x, and then we integrate and we get 6x power 1 plus 1 divided by the new power that we got. So in this case, the power is x power 1 plus 1 and we get power squared. That new power will be divided and the final answer will be 3x squared.
In integration, there are only two topics, which is indefined integral and defined integral. In this video, we will only focus on defined integral.
Application of integration to find area. One of the use of integration is to find area. For example, a civil engineer might want to know the area of a piece of wood used to do formwork to build an art of a building. A fashion designer might want to know total fabric area needed to make curtain. I want to calculate equation for the error. The question is calculate the error of the shape in the diagram below. For this question have two shape. Shape 1 equal to L1 and shape 2 equal to L2. So I want to explain the first shape L1. L1 equal integral upper limit 2 and lower limit 0 y ds. Next, integral upper limit 2 and lower limit 0 open bracket x square minus cx plus a close bracket and ds. Next, we integrate them and get the answer for x power of 3 over 3 minus cx square over 2 plus ax dx. After we get the answer for integrate, we replace the value of x with value upper limit 2. Open bracket to power of 3 over 3 minus c open bracket 2 square over 2 plus a open bracket 2, and we get the answer a over 3 minus 3 open bracket 4 plus 6 minus 0, and last we get the answer for area L1. The answer is 20 over 3.
Thank you, Saiful. I will now be taking this part. Now, let us find the second area, which is L2. L2 is equal to integrate y dx with lower limit is 2 and the upper limit is 4. First, insert the equation that is equal to y. So it will be integrate x squared minus 6x plus 8 dx. Then we integrate them. We get x cubed divided by 3 minus 6x squared divided by 2 plus 8x. And don't forget to put the lower and upper limit. Thirdly, x in the calculation will change with the upper limit, which is 4 in the calculation, and then minus them with lower limit part. And lastly, we get the final answer is negative 4 divided by 3. And lastly, we sum up the two areas. So L1 plus L2 equal to 20 divided by 3 plus 4 divided by 3, and then we get 8 units square. We use unit as the question doesn't identify any unit SI, such as meter or millimeter or anything else. So we just use unit instead.
Application of integration to find volume. One very useful application of integration is finding the volume of curved figures that we could typically get without using calculus, since we already know that we can use the integral to get the area between the x and y axis and a function. We can also get the volume of the figure by rotating the figures around either one of the axes.
So, the question for volume is, calculate the volume generated in a figure below when a shaped region is rotated through 360 degrees on the y-axis. So, I will show you guys how to answer this question. The first step, all you guys need to do is just do this equation, which is pi integrate maximum point 3, minimum point 0, and x power of 2 dy. How did I get this maximum point and minimum point? All you need to do is just take it from the figure that 3 is and 0 there. So for the next step is substitute x power of 2 to become y power of 2 minus 5y. This will become our new equation, which is pi integrate 3 0 open bracket y power of 2 minus 5y close bracket power of 2 dy. And we need to do some factorization, which is open bracket y power of 2 minus 5y close bracket open bracket again y power of 2 minus 5y close bracket. And with this and do some calculation, we will get our new equation that pi integrate 3 0 open bracket y power of 4 minus 5y power of 3 plus 25y power of 2 close bracket dy. So for the next step is we need to do the integrate that is pi open bracket y power of 5 over 5 minus 10y power of 4 over 4 plus 25y power of 3 over 3 close bracket 3 and 0. So for the next step is we need to do some calculation to get this equation, which is pi open bracket 243 over 5 minus 405 over 2 plus 225 minus 0 close bracket. So for the answer is 71 1 over 10 pi unit 3.
So, what is the use of all integration that we just did in civil engineering? There is a number of methods of calculations, among which are functions, differentiation, and integration. Application of integrals is applied in various fields like mathematics, science, engineering, etc. There are many applications of integrals, out of which some are Find the center of mass, which is centroid, of an area having curved sides. To find the area between two curves. Third, to find the area under a curve. And lastly, the average value of a curve.
Application of integration in case engineering. In this section, we use definite integral to calculate the force exerted on a dam when the reservoir is full, and we examine how changing water level affect that force. Hydrostatic force is only one of the many applications of definite integrals. From geometric applications such as surface area and volume to physical applications such as mass and work to growth and decay model. Definite integrals are powerful tools to help us to understand and model the world around us.
Application area in civil engineering. 1. Surveying. Looking over is the system of deciding the overall position of various highlight points above or underneath the outside of the earth by method for immediate or around bird estimation, largely speaking to them on a sheet of paper, not plan or guide. Studying is the science and craft of making every single basic estimation to decide the general position of focus of physical and social subsatellites above, on or underneath the outside of the earth, and to portray them in a usable frame, or to set up the situation of focus or satellites. A mean and overview, and surveyors utilize different devices to carry out their responsibility effectively. GPS beneficiaries, crystal, 3D scanner, radio communicator, computerized dimension, dumpy dimension, and reviewing, programming, and so forth. Thank you.
Application of volume in civil engineering. In the design and planning of many engineering project, volume calculation of various quantity use field measurement and required for proper alignment of roads, work canal and swell lines, soil and water conservation from pond and per qualification. Pond concern a large amount of other work is required. Calculating the number of various materials such as coal, gravel and other materials required to verify stored file as the estimate the capacities of bins, tanks and other containers.
Started talking to you, I don't know what I said, but the next thing I knew is that I held you in my arms and you asked what we should do.